Hey guys, today let's understand the new set analysis syntax introduced by Click with a simple example. So I have this simple data set product category, year and sales. So I have this measure, right, sum of sales. Okay, this is our overall sales. Now let me create a simple set analysis. Let's say I want to see the sum of sales for the year 2023. Okay, so this is how our normal syntax will look like, right? So curly brace, angle brace, and year is equal to 2023. So this is going to return the sales for 2023, right? So this is how our normal set syntax will look like, right? So now what they have introduced is, so we can bring this expression outside the aggregate function sum. Okay, so basically we can bring this portion out and move it to the outer part, so this outer expression will still have effect on this. Okay, so we could see the same results for in both the case, right? So this is the new syntax which is being introduced now. So what's the benefit of that, right? So let's say I have a master measure. Okay, I have already created one, total sales, which is nothing but my sum of sales. The name is total space sales. Okay, so if I have a master measure and if I'm going to reuse it in multiple places, I can simply refer it over here, right? So I can simply call my master measure name, and I can pass additional filters on top of it. So this master measure can be a straightforward, simple sum of sales, or it could be a complex formula with multiple set analysis. So whatever the master measure is, we can simply reuse it in multiple places, and on top of that, we can add our own custom filters, outer expressions, right? So that's the benefit we get out of that. Okay, so we could see it still returns the same result, right? So we can also pass multiple values. Let me show you a simple example. Mm, let's say I'll add one more value called category. Category is equal to a, being a string, it will be inside single quotes. So 2023 category A. Okay, so this is the sales for category A in the year 2023. Let's quickly validate that. Year 2023, 100, right? You see here. Yeah. So similarly, we can add multiple fields and multiple filters on top of it. So the outer expression will have effect on the following for aggregation sum of sales. So if I want to limit this, right, we can basically define a scope. So let's say I have one more formula, sum of sales. Now we should see 200. So this outer expression we see here is applied to both the aggregate function sum of sales and this sum of sales. Okay. Instead, if I want to restrict this, then I have to put this inside a bracket. We call this as a lexical scope, lexical scoping. So whatever is part of this scope, right? So this outer expression is going to be applied only for this aggregate function which is within this bracket. So this will act as an independent formula, and this expression effect is only for this, right? With whatever is defined within this bracket. So this lexical scope. Okay. So now we see 2350 is the overall sales plus 100, right? This 100. So 2450 is what we see. So this is how we can define the scope, and we can define where this outer expression should have an effect, right? So basically we can control the effect of outer expression. Let us explore one more scenario where the identifier is defined. Okay, let's see how it works in case of an identifier. Let me copy this. Let me add a set inside this function, aggregate function. So let me say category is equal to A. So now sum of sales will be calculated based on this plus this, right? So we should get sales for category A along with 2023. Okay, so it works as expected. So we are getting 100. Now if I add a identifier, let's say 1 here. So what it, I'm ignoring this. So ideally what this means is sum of sales for the category A, and we are, it is going to ignore all other filter selections, right, across the data model. So only category A is going to be considered for sum of sales. Now even though we have this outer expression, it is still going to work the same way since I have an identifier defined within the inner expression, right? Even though I put this entire thing in scope. Okay, so what I get is sales for category A. So category A, the overall sales is 250. So it is not considering the outer expression 2023 since it has got an identifier defined inside, right? So when an identifier is defined, preference will be given to the inner expression identifier. Okay, so this is one scenario to be aware of. We'll finally see one more benefit of this new syntax. Um, Let me copy this. Let's say I want to divide sum of sales for the year 2023 by count of category for the year 2023. Okay, so normally this is how we would write, right? So it gives me 190. Instead, now with the help of new syntax, what we can do is I can totally remove it here from both the places, and I'll keep it outside as a common outer expression, and I'll put this entire thing into the scope. See, scope is required only if we want to restrict it. If there is no scope defined, this outer expression is going to be applied across all the formulas. Okay, so whether defined or not, this outer scope expression is going to be applied to both the formulas now. Okay, so you could see it is returning the same result, right? So this is one benefit of the new syntax which is introduced. So we don't have to repeat it in multiple places. I can have it defined as a common expression outside, and which is going to be applied to all my aggregate functions, right? So this is one benefit of the new syntax. Hope we understood how the new set analysis syntax works. Please do let me know in the comment section for any clarification. Thanks for watching.